Let's continue the story about polynomials by multiplying two polynomials. For this first problem, we have a monomial times a trinomial, and this should look like the distributive property because it will act like the distributive property. When I multiply, I'm going to be bringing back my exponent rules. So 2m to the fourth times 3m to the second is 2 times 3, 6. M to the fourth, m to the second, that's 6 factors of m, plus 2m to the fourth times 5m would be 2 times 5, 10. 4 factors of m times another factor of m would be 5 factors of m. 2m to the fourth times 6 would just be 12m to the fourth. Okay, I have a monomial times a binomial. So I have 2/3 x to the third times 12x. 2/3 of 12 is 8. And I have 4 factors of x minus 2/3 of 21 is 14 and 3 factors of x. Now I have a binomial times a trinomial. And in that case, we're going to have to distribute 9x to all three terms. And then we're going to have to distribute -2 to all three terms, because multiplication is more like a party where everybody spends a little time with everybody else. At the end of all that multiplying, we'll need to look for like terms. So I have 9x times 8x squared, that's 72x to the third. 9x times -6x would be -54x squared. 9x times 1 is 9x. -2 times 8x squared is -16x squared. -2 times -6x is positive 12x. And -2 times 1 is -2. My 72x to the third has no like terms. My -54x squared and my -16x squared make -70x squared. My 9x and my -12x make 21x and my -2. Okay. Wow. A trinomial times a trinomial. So I'm going to have to multiply 2m squared times each of these, m times each of these, and -3 times each of these. I'm going to show you a technique that some of you may have seen in school, which would be to write it like a multiplication table. So I have 2m squared, I have an m, I have a -3, I have an m squared, a -4m, and a 5. I'm going to change colors here. And then I just treat it like a multiplication table. So I have 2m to the fourth, I have m to the third, I have -3m squared, I have -8m to the third, I have -4m squared, and I have positive 12m. I have 10m squared. I have 5m. I have -15. Let's go for yet another color. And we'll notice that on the diagonals, I have my like terms. So 2m to the fourth has no like terms. This is negative 7m to the third. This is 3m squared. This is 17m minus 15. So some people like the multiplication table as an organization strategy when we're multiplying really large uh, products. Okay, these are the ones that we tend to see the most often and enjoy the most. A binomial times a binomial. So we're going to multiply 7x times 2x and 7x times negative 5 and 3 times 2x and 3 times negative 5. A lot of teachers, and myself included, identify this as FOIL because we multiplied the first term in each bracket, the outside terms in each bracket, the inside terms in each bracket, and the last terms in each bracket. So my first terms make 14x squared. My outside terms make negative 35x. My inside terms make 6x. And my last terms make negative 15. My like terms are the outside insides. I get 14x squared minus 29x minus 15. Even if the numbers get messy, I can still use first, outside, inside, last. My first terms make negative 0.5x squared. My outside terms make positive 0.10x. My inside terms make positive 0.9x. And my last terms make negative 0.18. My inside-outside like terms come together, so negative 0.5x squared plus, well, if I call this 90, that's like a dime and 90 cents. That's $1. So that's 1x minus 0.18. If I had a product of three things, so this monomial and then times this binomial times this binomial, by the associative property, I can multiply anything I want first. So I usually choose to multiply the binomials first and then distribute the monomial. So my 5x to the fourth is going to hang out here. X times 3x is 3x squared. My outside terms make negative x. My inside terms make 9x. So that's 8x when I combine them. My last terms make negative 3. By doing a little bit of mental math, I saved myself a step. Now I'm going to distribute my monomial to each of these. I will have 15x to the sixth plus 40x to the fifth minus 15x to the fourth. Okay, that's my answer. I want to show it if I had done it differently. So if instead I had multiplied here, I would have had 5x to the fifth plus 15x to the fourth. And then I multiply that by 3x minus 1. My outside terms make 15x to the sixth. My outside terms make negative 5x to the fifth. My inside terms make 45x to the fifth. And my last terms make negative 15x to the fourth. These are my like terms. I have 15x to the sixth plus 40x to the fifth minus 15x to the fourth. Let's see. I got the same answer. So it doesn't matter by the associative property which two you multiply first, but I sort of like multiplying the binomials first.